Alright, cool. So now that we kind of learned how methods work, let's look at how custom classes use getters and setters and constructors, because they use the same functionality as methods. So I've just made a blank project right here called example getters, setters, and constructors. So in the package, I'm going to make a new class. We're going to call this the main class 2, and public static void main. Hit finish. Just to have it here. And we are going to create another class called tree, because those are the type of objects we're going to be making. And this tree is going to have a string name, a int amount water, and a boolean need sunlight. Oops. And we're just going to initialize these. Let's just say pine, and int amount of water will be 100. Nope. We're going to say the pine is going to have 1. Okay. And since it's an int, I don't need to end those. And in this, we're going to have a method called print my info. And in it, we're going to call system.out.print. And we're going to say, okay, this dot name plus needs plus this dot amount water plus gallons a day, and does it insert, I'll hit insert just to go to the next line, and does it need sunlight plus need sunlight. Okay. The only reason I'm putting this dot is because it's not necessary, but I'm only doing it to separate because it's all blue, so I wanted the variables to be kind of distinguishable by putting this dot. Okay, so let's just test it out real quick. Just the main class 2. So we're going to make an object of the tree. Tree pine equals new tree. And we're going to call pine.printMyInfo, because this method right here, printMyInfo, is in the pine class, or the tree class. So what we've done is we've taken the tree class and we've made an object out of it. This is the same thing as having string pine, but this was not type string, this is type tree. We're using a type tree, and we're going to call it a pine. And the value of it is a new instance of it. So we have a new object labeled pine, and the pine object has a method inside of it called printMyInfo. And whenever we call it, it should print out the name of the type of tree, the amount of water in gallons per day, and does it need sunlight, true or false. So let's just run this real quick. Pine needs 1 gallon a day, and does it need sunlight, ? False. Let's put a space after that question mark. Okay, so we know that it's working. So let's look at this. Let's change this to pine, big tree. And we're going to put big tree dot name. See, we're going to set the value, the variable values by taking the object itself dot variable name, and then it's just like saying name equals pine, except we're going to say big tree name equals oak, right? Because we're not changing these variables of the class itself. That's important to note. We're not changing these variables of the class itself, but rather each instance has its own set of these variables. We're just going to delete these. That way it kind of makes it easier to understand that whenever we create an object of tree, they're going to come with these variables, but they're going to have no value. That's why we're setting them right here. Big tree dot amount of water equals, let's say this one needs 500 gallons a day, and big tree needs sunlight, boolean is equal to true. So we got a big tree, and we're gonna big tree dot print my info, and let's run this. Oak needs 500 gallons a day and doesn't need sunlight, true. See, the important part about this is this print my info method comes with the class. We're creating an object of this class. This is the blueprint. This is the object, right? We're making an object out of the blueprint tree. See how that works? It comes with all of its own variables and its own copy of the method. And that's cool because the method doesn't explicitly print anything, but it actually takes the value of the variables of this instance and it prints it with it. So that's why we can enter in this new stuff. And we call the print my info. In fact, watch this. We're going to put this at the beginning, and this might not work. Null needs 0 gallons a day and doesn't need sunlight, false. So whenever you declare variables, sometimes they come with default values, and if you declare a string, it's going to come with the default value of null, and int's going to come with the default value of 0 and doesn't need sunlight, false. So anytime you create a boolean, it's going to be false just by default, and that's okay. But that's what we wanted to see. If we don't declare the variable or the variable values before we call the print my info, it prints out the null and stuff because it's got just the default. But we've assigned it values, so when we call it down here again, one will be null, the other one will be the oak. See? Okay. Now that's all good and all, but this is a lot to type out. Right? So what we can do is make a constructor for this tree. Basically, each time you make a class like this, it comes with the default constructor, and it looks just like this. Public tree, and that's it. If it makes it easier to look at it, it looks just like that, right? That is a given with any. So, but if we declare a different type of constructor, we lose the default constructor. So we're going to leave it there, but we're also going to say, just like a method call, we're going to say string name in int water in boolean need sunlight in, right? So these parameters are variables that we're going to pass to the tree object. I'm sorry, let me rephrase that. Whenever we create an object out of the tree blueprint, we can construct it as we create the object. So instead of creating a blank slate like this right here, we have created a blank slate of the class, which means all the variables have no values. But if we give it a constructor, which looks like this, it's public, and then it's the name of the class, the tree is public, the name of the class, and then the parameters you want in it. And then in here, you can declare some actions. So what we're going to say is this dot name equals name in. This dot amount water equals water in. This dot needs sunlight equals need sunlight in. Now, whenever we declare a new tree, we pass it 3 parameters: the name, the water in, and the does it need sunlight. And then inside of the constructor, it says, okay, you've given me these variables, these parameters to construct a tree object with. Let me plug this stuff you passed to me and build the object with it. And we're going to go ahead and build the name variable with the name you passed me. We're going to build the amount of water variable with the water int you passed me, and so on. So now what we can do is whenever we say we're going to do the same thing right here, but instead of all that this.name or bigtree.name and all that declaring the variables like that, why don't we just construct it as we declare it? So new tree, and we're going to do oak. And what was the order that I had it in? So we're going to have a string name, int water in, boolean. So string int boolean. So there's our string. Our int is going to be 300 gallons per day. And do we need sunlight? This oak does not. It's false. So you see how the red lines go away because it says, hey, you've constructed a tree object with parameters that match the blueprint. String int boolean. String int boolean. Right? The new tree, we constructed it. So now, watch this, big tree.print my info. So because we've already given the variables the values of this tree object, whenever we call the print my info, it's going to print it because we've constructed it. Okay, oak needs 300 gallons a day, and does it need sunlight? False. Very cool. Let's do another one. Little tree equals new tree. We're going to call this Bradford. How do you spell Bradford pear? Actually, you know what? We're going to call this one a Japanese maple, and it only needs 20 gallons per day. And these numbers are not true, by the way. And does it need sunlight? We're going to say true, right? So now we got big tree, oak, and we've constructed it. And now we're going to call little tree dot print my info. So let's see what happens. See that? See, this is why it's so cool. Like, you can construct objects however you want to. You can make any kind of constructors you want to too. Maybe you want to make a constructor where you don't give it the sunlight. So now we can call tree medium tree equals new tree, and the name of it is going to be apple tree, comma, parameter separation right there. it only requires 10 gallons per day, and that's all we're going to give it, right? We can construct this object with just giving it a name and an int for the number of gallons, because we have a constructor that accepts two parameters, string and int. See how that works? And then it assigns the past parameters to this new object. But you see, the needs sunlight isn't going to be addressed in it. Either A, you can leave it at the default, or you can just say, you know what? Every single time someone constructs a tree and they don't tell it if it needs sunlight, we're just going to automatically say it's true, right? So now, medium tree dot print my info, and we're going to run that. Apple tree needs 10 gallons a day and doesn't need sunlight, true. See how that works? Watch this. Let me take this away. And let me run the same class. That's all I did, was I took away the declaration, or the assignment of the Boolean needs sunlight in this constructor that only has two parameters in. So let's print it again. So the apple tree will need sunlight. Will not need sunlight, because if you remember, the default value for a variable of type Boolean that's not assigned is going to be false. See that? I hope I didn't just confuse you with that. But basically, we constructed a tree object and only gave it a name and an amount of water to do. And because we didn't do anything with the Boolean variable, it resorts to being false, because if you don't assign it true, it's just automatically false. That's all that happened there. Okay, so why are getters and setters important too? Let's look at this. We are going to have, up under our variables, getters and setters, and I think there's a way we can generate them. Right click, source, generate getters and setters. There we go. For all three variables. So getters and setters are nothing more than methods. That's it. And now here we are. And if you remember from the previous video, you see how it says public string getName? That means whatever place calls the getName method, it's going to return the name of that object from the object. The name variable in the object of type tree. So public void set name. So that means we can set the name if we want to. I always like to put my setters above my getters. I'm just picky. And we're going to leave print my info the same. So if you look, you see the name right here is this name, and then this dot name is this object instance. So we're going to change this to name in to make it easier. And we're going to return the name from the object. This dot name is not required, but it makes it easier as you're learning. Amount water in. That way you can see how the variables line up. We're just going to do that for all of them. Need sunlight in. Okay, so let's see how this works. Why are getters and setters important? Because you can change, let's say you don't want to construct a whole new object. Let's say I have the perfect object. I have created an object, I've constructed it, but you know what? The name has changed, or the amount of water has changed, depending on where you're at, So let's just look at this. Let's take the big tree. We're going to go to big tree, and we're going to say big tree dot print my info. and it's going to print the info. And then we're going to say bigtree dot set name, and it takes a string parameter, the name in. You see how it says string name in? That's what we've declared over here. Set name, string name in, string name in, string name in right here. So bigtree dot set name. Let's say it's a redwood now. And now bigtree, since we have changed our info, we've changed our name, print your info again. Let's just see how this works. Oak needs 300 gallons a day and doesn't need sunlight. False. We've changed the, right here we did the bigtree.set name redwood. So now it's not oak anymore. We've constructed the bigtree object by the name of oak. And we've printed the info. But then we changed the name from oak to redwood with the set name method. Okay? Redwood needs 300 gallons a day. And does it need sunlight? False. Cool. So down here, let's make a method called print the number of gallons per day. Public static void print the number of gallons per day. And we are going to pass it an int gallons per day in. And then in here we're going to say system.out.println gallons per day in. Right? Okay. So let's call this print the number of gallons per day method. Let's call it. We're going to take away the redwood and the changed info. And we have our bigtree object still constructed. Oak 300 gallons per day. It does not need sunlight. And we're going to call the print the number of gallons per day. And as you can see, it accepts an int parameter. So why don't we grab the gallons per day from the bigtree object? Bigtree.get amount water. You see how we used a method call from an object to pass to another method? Let's look at that tree blueprint again, the tree class, and the get amount of water method. Let's look at that. Get amount of water, public int. See, it returns an int. We call the method and it returns an int value. That int's this right here is an int's value. It's just got all this stuff to get that int value. Print the number of gallons per day, and we're going to call it. So let's run this. And it should say 300. See how that happens? Method calls, passing information to methods. A big advantage in object-oriented programming. But that's kind of why you have getters and setters. And yeah, it kind of seems simple, like, oh, okay, so you can just get and change the name. But it's the use of, like, it's the understanding of how the layout of it is and how it works, how it interacts with each other. Because right now all we're doing is interchanging strings, ints, and primitive values. But you can actually construct objects with objects and stuff like that. So it really can get complicated. But if you understand the fundamentals part, you're able to track down and uncomplicate something that looks complicated. Just picture it all as a string, right? Or an int. But if it's an object, go to the objects class. Go to the blueprint. Look how it's set up. So whenever it's passed as a parameter, you'll know exactly how it'll function or how it should function, what methods it has. But let's just look at how it can really be used. Watch this. Array list of type tree, trees equals new array list. We're going to import this class. Now we might have to declare this. Oh, we got to put our parentheses there. It's the default constructor. Empty parentheses is a default constructor. That means you're creating a new object. Clean slate, nothing in it. So instead of printing the info right here, and instead of calling that method, what we're going to do is big tree. Okay, yeah. And then we're going to add that to our trees array list. Right? Tree, little tree equals new tree. We're going to say the Japanese maple. And this Japanese maple only needs 20 gallons, and it needs sunlight. And then we're going to add it to our array list. Oh, not at all. Okay, I'm just going to copy this and paste it to create another. And we're going to call this medium tree. And this medium tree is going to be the apple tree. And it needs also 300 gallons. And it needs some. Okay, so basically, all we've just done is created 3 new tree objects. Hold on. Okay, we've created 3 new tree objects. We've created an array list of trees. And each of those trees we have added into our array list. Right? And so now what we can do, here's how the getters and setters can function. So let's do a loop. And we want to take every single tree that requires 300 gallons of water per day and put them in another array list. So we're going to declare another array list. And we're going to, let's see. Actually, what we're going to do, I'm sorry, let me rephrase this. What we're going to do is we're going to find every tree that requires 300 gallons of water, and we're going to print the name. Okay? So what we're going to do is create a loop. So for int I equals 0, I less than trees.size. That way we know we won't go to an array out of bounds index or an out of bounds index. Okay, and then I plus plus. My dog coughing right behind me. Okay, so there is the for loop. And so what we're going to do, let's see, how can we do this? Yep, that's what we'll do. So we'll do trees.get, because just like we got getters and setters in this class, we have a lot of the public like classes and stuff like that offered by Java and Android and all that. They have their own getters and setters. You will see get.get and .set everywhere. So trees.get, and we're going to get the tree at position 0 at first, and then we're going to say let's assign this to a variable tree temp tree equals trees.getI, and we're going to say if temp tree.get name dot equals, I'm sorry, we're not getting name, we're getting the amount of water. Sorry. Get amount water. So if temp tree dot get amount water is equal to 300, system dot out dot print temp tree dot get name. Okay. So basically what we've done is we've got our array list of trees, created tree objects, we've added them into the array list, and now we're looping through each and every tree in that array list, and we're checking if the tree amount of water is equal to 300, and if it is, we're going to print that tree's name. So let's run this and see if it works. So it should come out and just print us two trees, oak and apple tree. There you go. So yeah, that's kind of like some simple examples of how getters and setters can be used. And as you can see, the array list has its own get and set methods. So yep, very powerful stuff.